Alright, let's do the video to accompany tutorial 2 for electric. So videos, written video tutorials. So we're going to make this one now. So we'll go over here to tutorial 2 and I'm going to right click and save link as in IC:electric. And we already have one there, but let's go ahead and overwrite it. Okay, so here's the tutorial, quite long. I'm going to try to stick to it as close as possible. I'm assuming you've went through tutorial 1 already, which was less than a half hour in video, but probably would take you longer if you were doing it from just on your own. So we'll open up electric. We'll arrange the windows here, just like the beginning of tutorial 2 shows. Make this message window, since we don't have much screen, smaller. And do we'll just do it manually. Get used to having key bindings, and it gets a little more slow. You're a little slower. So open library, tutorial 1. And the first thing it says, I've printed out this again, the first thing it says is to save this library as tutorial 2. So let's go File, Save Library As, Tutorial 2. And let's see what else. Says save the file C5. Let's go back up here, save these. So right click, save link. So these we'll need for our SPICE models. So it's in electric, so we'll save it. Okay. And then now we still have our divider from tutorial 1, but let's make a new cell that's called NMOS IV. So we go to Cell, New Cell, NMOS IV, and it's a schematic. Okay, so there it is. We're there. And it says to go grab an NMOS node. So let's do that. We'll grab that and place it in here. Then let's do a Control-I. Or actually, I like using Q, so let me just pause for a moment and add that bind key. So we'll go to Key Bindings, Edit, Properties, Edit Object Properties, Add, Q, Add, Remove All. Make sure we do that or it'll cycle through the windows and we'll have all kinds of crazy behavior. Okay, so we'll select that node. Let's hit Fit, Query, and it says to change the length to 10. All right. Next, Control click, and we can't use, so we want to move these around, so hit Control and click until you get this, and you can't use Edit Rotate because that only works for nodes. And so what we have to do instead is edit the object properties and go to Rotation 270, Apply. We could leave this window open if we wanted to. If we had a bigger screen, I guess, and rotate that one 270 as well. And I think in the tutorial I set the grid to 0.25. I'm just going to leave it at 0.5 here. Let's move these out of the way. Let's move this up a little. Okay. Then we need to set a SPICE model, and so we don't want to do this every single time, so we'll do this once and then we'll just copy these from now on. So we go up to Tools, and so if we don't have the SPICE model, it won't simulate correctly. So Simulation, Set SPICE Model, hit Fit, Q, and then Rotation, or let's put the SPICE model name, and that's NMOS. And you know what, let's just go verify that real quick. Query that, and go back and rotate it 270 as well. And use the arrow keys to move it just to be different instead of the mouse. Okay, so there's our width is 10, length is 2. Spice model name is NMOS. So let me go take a look in the right click on Start. Go up to Electric, and we saved our Spice models there. And our NMOS name is NMOS, and our PMOS name is PMOS. That's easy to remember. Okay. All right. So we're good to go there. And now let's do the same thing for a PMOS. So we need to make a PMOS cell. So we go to Cell, New Cell, PMOS _ IV, and hit OK. And then go in there, Components, drop that down, Fit, Query, change the width to 10, OK, Control click until we query that, go to 270, OK. Let's use our arrows and move it up a little bit. Query, rotation, 270, OK. Select the node, go to Tools, Spice Model, Set Spice Model. If we wanted to set an M factor multiplier, we'd set it here. Set Spice Model, Fit, select that, Query, PMOS, rotation, 270. Use the arrows again. Oops. Okay. Now, this is a 3-terminal. When we do our layouts, we're going to want to have access to all 4 terminals. So let's go Select, Edit, Change, and change the transistor to a 4-port device. Apply. And most of the time in CMOS, the source and the bulk are at the top of the device for the PMOS because current flows down and the drain is at the bottom, vice versa for the NMOS. But let's select this node and simply mirror up, down. All right, we're good to go. Now I think we need to do, no, we don't need to do that for our NMOS. But our PMOS looking good, so that's source, bulk, or well for us. Let's move this out of the way a little bit. Source, well, gate, drain. Drain, gate, source. Oh, we need to change this one too, don't we? So we could hit C or just go to Edit, Change, and go up to 4-port transistor, Apply, Done. And let's see. Okay, we're done. So now we need to do our layouts. Okay, so let's make a cell. Let's see, the next one is let's make a layout views of these cells. So Cell, New Cell, Layout, NMOS IV. Okay, and now notice it put it in its group. We have our schematic view and our layout view. And we'll go over to our components and we'll pick NMOS, throw it down, and the highlight box is in the middle. You can see the 4 ports. We have a connection on poly on each of the sides, here and here, and then on active there and there. So now let's go down. So it's an NMOS device we just put down. So the source and drain are made with N active. So we'll go hit X a few times and zoom out. And did I skip over changing the width of the device? So I guess not yet. Let's move this a little bit away. Hit Fit. Press F5. No design rules errors yet. And then we need a connection to poly for metal 1 there. And then last but not least, we need a connection. So it's an NMOS device. So the source and drain are N active, these nodes. And then we need for the bulk, we need to connect the bulk to the P well. And so we'll just go throw that over here. And so these are our 4 connections. We haven't wired the MOSFET together, but we have our drain, our gate, our source, and our bulk. Okay, so we're ready to size everything. First thing let's do, let's go get the MOSFET, just make sure I stay consistent here, and edit its properties and change its width to 10. Okay. And then, following the tutorials, we'll select that and press Shift so we get both of these, and then edit their properties and change the X size of each of those to 10 as well, so it lines up with the width of the device. And let's do the same thing for this one. Query X size 10. Okay. Now we're ready to connect things together. So we'll left click here, then go up here and right click. So notice we're using this arc right here, which is inactive. Okay, we just connected. So we can do several things at this point. We could just move the arc down here till it's adjacent to the MOSFET, hit Fit, and then press F5. Whoops, wrong, that was F6, F5. 2 errors, let's see what they are. Oh, I connected those up, so let's move this away. Now let's do F5. Okay, no errors. And so this is the drain of our device, moved it down. And then next, let's connect the, oh, you know what, I left off, we didn't set the SPICE model for this transistor, so let's do that. So SPICE, set SPICE model, press Control, and go in here, Query, and this is an NMOS. And there's our NMOS, so we've set the SPICE model. That's really important and easy to forget because you get bogged down in doing the layout, but you don't want to have to do that with all the transistors later. Okay, so next we want to connect up the source. And so let's select the node here, go up. So this time I selected the inactive node. Now I go up and make my connection. And for some reason when here, let's do this because I was off-centered. Let's move this over to try to get the wider arc. Okay, it made a wider connection, so I want to make sure I make the mistake that I made in the, or do it the same way that I did it in the tutorial. So I got all this extra stuff here. In fact, if I draw a box around here, I see there's an arc. This is a red arc there. There's an arc here, an arc here. And so if I move this over, eventually it'll move the arc as well. Okay, but let's say I didn't want to do that. Let me hit Control Z a bunch of times and go back to where I was. If I change the arc here to be, let's press more, to be rigid, and I hit OK, now when I move it, it moves the attached node as well. Okay, so we can query that and go back to non-rigid. OK. We can select this and we get our behavior that we add here. And we can move it into place if we want. Just playing around. We can move it back, and then we can, I'm using the arrow buttons, and we can use the mouse as well, and we can move this up. But now, when I get close, let's move this over here. Like this, I've got this extra arc that extends over. So when I hit F5, it says I've got 5 errors. So if I start stepping through the errors, I see that that arc overlaps the other transistors, the spacing, the inactive, the arc inactive touches and transistor, so I need to fix that. So I'm going to grab the arc by pressing Control until I make it active, and I don't want it to extend all the way over here. In other words, what I want, of course, if I'd aligned things up, none of this would have happened, but I didn't. I don't want either end to extend, so I hit Apply, and now the arc stays down here. It doesn't extend all the way up. So now when I hit F5, I don't have any errors. Okay. You can play around with that. It's really easy once you figure it out, and it's really powerful because it allows you to draw a layout like you draw schematics, and so you can be rather quick. Okay, so let's go next. Let's see what do we have in the tutorial. Lots of figures here. We want to connect up the poly gate, so we left click, right click, and then let's try to get it closer to the field here of fit, and press F5, and that's what we get, and no errors. And last but not least, you remember last time when we did our tutorial, we went to Tools and Well Check rather, and it says that the P well must be connected to ground, and we have our connection to P well right here. And so we're going to have an issue when we check to see if the wells, actually let's do a well check right now. I'll do it the long way instead of pressing W. We have two errors. One is this well isn't tied to ground, and the other is this one isn't tied to ground, or there's no contact in this area. And then this well here, the X here, indicates that that one's not tied to ground, and so this one is there's no well contact in this area. So we'll fix that in a moment. First we can just move this up so that there is a well. So now this crosshatch is one whole well. Hit F5. And we see, okay, there we have the well is in that area. Whoops, sorry, well check. We only have one error, and that is that the well's not connected to ground. Okay, so let's fix that. What I'm going to do, I'm going to go here, left click, and then I'm going to right click and make a mistake. Maybe I'll make a mistake. Nope. I'm going to take this pin and I'm going to export this pin. And I'm going to export the pin, create export, leave it at unknown as GND. Now, when I do my well check, it says, hey, this is connected to ground. And I have to use lowercase because this associates ground with the symbol ground when we do our schematics. Okay? So it's an export. Notice I could have also gone up here and said, oh, I'm going to name this GND, and made it the same size, and it looks very similar. Well, I'll hit Control Z and undo it. So I got to make sure I export the pin. Okay. I'm going to repeat this for the other connections. Go here to the right, and let's do a Control E. Or actually, let me not use too many binding keys so that I go fast enough as it is. Create export and call that source. Go up here, create export, call that drain. Oops, grab that again, Control E, drain. And go over here, Control E, gate. And then we come over here. Notice I selected the pin and I used the arrows to move that over. Hit fit, and we've got our nice little transistor drawn on the screen. And let's go ahead and save the library as it says in the tutorial. And let's do the same thing for the PMOS cell. So we have to create the PMOS layout. So let's do an F5, DRC, a well check. Okay, no issues. Save. Let's do cell, new cell, and then PMOS underscore IV, and then hit OK. So layout, PMOS IV, OK, and it puts it in this program group. So let's see, we'll go grab a PMOS transistor, throw it down, while it's selected, hit query, go to 10, OK, while it's selected, go to tools, set spice model, go down, use control to get it that what I want to select, change that to PMOS, Hit OK, hit fit, looking good. Then we need P active for the source and drain. Why that's active, just to save a little time, we'll go to 10. Do another one, P active here. Go to 10. And then put up metal 1, poly 1 contact down. And then last but not least, we need an N well. So let's throw that up here too. So let's wire everything together just like we did before. Move that down. Try not to create gratuitous problems. Move that down. Left click, right click, move that over. Oh yeah, query. Oops, cancel. Query. Let's set X size as 10. Now for some reason, the node comes up with a Y size of 5, and that gives a DRC error, which we'll find if we DRC it. So let's just change it to 6. And now hit F5, no errors, no DRC errors. Let's go export everything. Fit, go up. Let's do a, what did we call that export? In the, we called it W here. So we'll do a Control E, W, fit, then go over here. Control E, source, go over here. Control E, drain, whoops, yeah, this is the PMOS, so drain, and then go over here. Control E, gate. Now if I would have picked one of these nodes and pulled out and right clicked out here and got P active, if I would have got the P active here, that means that this is selected, but I would have had to go over to the menu and select the metal to get it selected correctly. So well check, no problem, because we don't have to have our well connected to VDD. Metal is the source, metal is the drain, a gate is the metal connection here. And so we'll go from there. And let's see, what are we doing now? Oh yeah, we got to add spice code. So let's go over to miscellaneous, spice code, and I think we're doing it on query that, multi-line, set the text size, it's circled in the tutorial to 2, and then we'll say there's a voltage source VS from S, which is this node right here, to ground, DC 0. Then from the well, VW, W0, DC 0. VG from gate to 0. We're just putting DC 0 voltage here, and then we'll change them with our spice code or with our statement. And VD from D0, DC 0, dot DC, VD from 0 to -5, -1 milli, VG 0, -5, -1, and then we need to include, and we put those models at the beginning of the tutorial in C:(electric) C5_models.txt. Okay. Fit. Alright, I think we're good to go. Let me just make sure. Source, well, gate, drain, and I could call this body. I don't know why I called it well, but it's the same thing. And gate, we're just sweeping VD from -5 there. Alright, we're ready to roll them. So we go up and hit Tools, simulation built in and we're still set up. Nope, simulation spice and write spice deck, and we have it automatically sim. And then we want to plot the drain current, or let's just plot the source current so it'll be positive. Drain and source current are the same, just opposite. And there's our current. Woohoo! And we can plot other things if we want. We can close this and then stretch this out. Go over to Explorer and do I of V drain, or I of V source rather. Let's pull it over there. Get rid of this one, hit delete, hit fit so it shows up, and then we see we've got what we show in the tutorial. Alright, let's go add the spice code here. Control C, hit save real quick. Go back over to the NMOS, query that, VS0 VW. I don't need the VW, that's there, but it doesn't do anything because we've got it connected to ground here. Then .dc VD05, just make it positive, it's complementary. Gate, whoops, that's not good. And minus or 1. And then I think that's it. We'll find out. Hit save. And then tools, simulation, write spice deck. And then plot I of the drain. Oh, whoops. Let's flip it around. I of the source, since they're equal and opposite. And what did we get? Does that match the... Yes, it does. So close this. Electrics probe will run. Let's make the waveform viewer a little wider instead of dragging it out. And I'm trying to do different things. And then let's pull the ID over here, and there's our curves. Looking good. How exciting. Now we need to do the same thing for schematics. And let's copy our spice code. So let's do a Control C. And let's expand it a little bit. Control V. Ooh, that's way too big. What did we say? Let's shrink it. We copied it in there. What does the tutorial say? What size to use to shrink that text? Press Control I. And go 2 to 0.5. OK. And let's just set that right there. Let's do the same thing for the PMOS while we're at it, since I'll remember. Control C. Expand. Control V. Query. Alrighty. And let's go back to the NMOS. Oh yeah. And let's grab a ground symbol because we know lowercase g and d is equivalent to the ground. Whoops, wrong one. Let's go to the NMOS and press expand a little bit first. Now this symbol, in my opinion, is a little bit too big, so I'm going to go to Edit, Selected, Edit, Size, Interactively. Press Control G to turn on the grid, and then with that I'm going to drag it up so it looks like that. And to me that looks like the perfect size ground for the symbol. And so I'll often copy that. And then now I want to wire up, so left click over here, right click there, right click there, left click, right click, right click, left click, right click, left click, right click. Now here's where I can make a mistake. I could double click on this and call it D. That would be wrong. And it would look like it's correct, but it's not an export. And I want these to be able to export. So I'll hit Control Z, go over here, press Control, Control E, and go to drain. Say OK. Do a Control E, go to gate. OK. Control E, and I called this source. OK, notice on all those exports, which was export Control E, I left the characteristics as unknown. So let me hit F5 to see if I made any errors. No errors. So now let's press L or do an LVS, or in other words an NCC. Let's compare the schematic and the layout. And they match, and so I'm ready to sim. And we want right SPICE deck, and then ID of the NMOS, looking good. Close that, pull this up, what remembered at that time, and go ID of the NMOS. There we go. Alright, so it matches. NCC works, DRC works. Going over here, we don't have well errors because we connected our P well to ground. Let's turn the grid off, Control G. And the window toggle grid is Control G. Now let's do the same thing for the PMOS. Let me remind myself what I used. W for the body, G for the gate, source and drain. So let's see. So, alrighty. So we go over here, left click, right click, and since that's active, we can do a Control E and say W. Left click, right click, Control E, source, Control E, gate, Control E, drain, hit fit, and we can do a LVS. Oops. How come that's a lowercase w and an uppercase w in the other? So let me query that. Oh, I hit uppercase for some reason. Oh, I did that on purpose. Alright, so, whoops. That is, okay, there it's a lowercase. Looks the same to me for some reason. Do an LVS again, now it's clear. Do an F5, do a well check, everything's good. It matches the layout and the schematic match. So I go up to Tools, Simulation, right SPICE deck. Let's just connect that. Let's not. Let's go with IS. Alright, it's looking good. Close her up. Come over here. Do I of... Oops, let's get rid of this one. Hit delete, hit fit. Fit the windows and looking good. And I think that's it. So we can go ahead and save this, and we're ready to do something a little more complicated. Let's see, anything else we need here? Nope, so these are a lot of the basics in electric. We'll go do, in the next tutorial, we'll do a inverter. Alright, let's stop here.